Hello and welcome to a Maths with Harry lesson. In this video we're going to have a look at translating graphs. On the screen here I have a straight line, and it's the general straight line y is equal to x. So it's a straight line, it's got a gradient of 1, it passes through the origin here. I can do one of two things to that graph. I can either move it up and down, or I can move it left and right. So I can kind of do four things, but the two things I can do is something in the vertical direction or then something in the horizontal direction. So let's take the green line here and let's imagine I move that line y is equal to x up a little bit. Okay, that's something in the vertical direction. So I can move that line up, and then that means because I've moved that line up, it's now become a different line. We can see here, the black line is the line we started with, our y equals x, passes through the origin. I've then got the green line that I took from that line and I moved it up a little bit. Okay, I can see that it's now not crossing through the origin, it's crossing through this point here. Okay, so let's mark that on in orange. And it's also then crossing through this point here on the x-axis. Okay, so it's crossing through different points. If I was to move it down, let's say I got this blue line and I moved it down like this, for example, I could say that, well, then we can see there is an intersection point. Okay, so we can move the y equals x straight line up, or we can move it down. Okay, another thing that we could do, let's duplicate this and let's say, okay, let's start, and this time we will have let's go with a purple line. We'll have that straight line and we'll do something in the horizontal direction. So we can move it left or we can move it right. Let's move it to the right. So we move it something like that, okay? You can see, well, we still are not really doing much sort of change apart from the axes, okay? So we have an intersection there and we have an intersection there. Okay, and again, if I just duplicate what I can do, let's make this a orange. I can go to the left, so I can move it over here like that, and I'm not doing anything vertically, I'm just sliding it along. And again, we can see we have different intersection points. We have an intersection point there and an intersection point there. Okay, so those are the two things we can do. We could do up and down, or we can do left and right. We can also do a combination of those two things. So a combination would look something like this. Let's take the line and we could go a little bit to the right and a little bit up like that. Okay, but for the minute, we're just going to focus on going left and right or up and down. So I'm just going to get to the right page in the book, which is there, and let's have a look at different translations. Okay, so we have the graph of, I'll fill that in a minute, the graph of that is a translation of the graph y equals f of x by some vector. So let's fill in the information. If we have the graph of y equals f of x plus a, where a is a constant, a is a number, it could be 1, 2, 3, any number, it doesn't even have to be an integer, it's just a number that we add to f of x. That is a translation of the graph y equals f of x by the vector, and you should be used to vectors looking like that with two brackets, 0, a, okay, where this is x and this is y. Okay, so if we have a graph y equals f of x and we add something to that graph, what we do is we move that graph by this vector. Okay, so that was the green line here. If we add a to it, that means this intersection point must be a, because we've gone from being at the origin here, 0, and we've translated it by this vector, a, or 0, a. We've done nothing in the x, we've gone up by a in the y, so we moved it up. So this intersection point here, the y intersection, must be at the point a, okay? So that's what we do when we've got plus a outside. We've got f of x plus a. But what happens if we have the graph y equals f of x plus a? So this time we can see a difference. Here, when we do the vertical translation, up or down, we had a plus a here, so we were going up. If it was negative a, it would be down here. We could maybe say this is negative a, and then we translate the vector 0 minus a. Okay, that's the vertical translation. What happens if we have the a inside the bracket? So the graph of y equals f of x plus a is a translation. We're still translating, but the translation of the graph y equals f of x by this vector. And it is the vector minus a 0. So again, we've still got x and y. This is what's happening to x, this is what's happening to y. And this time, y is 0. And that's because it was, and I'll highlight it actually, it was, let's have a look, it was this line and this line, okay? We moved the purple line to the right, we moved the orange line to the left, okay? So we were doing nothing with the vertical direction. That's why we've got a vertical of 0 here. But we can see something quite important. We can see we have a plus a inside the bracket here. And when we've got a plus inside the brackets, the vector we move it to is a negative vector. So if we have y is f of x plus a, we move that by the vector minus a 0. So in other words, if we don't want to think about that in terms of vectors, what we do is we move the graph, if we've got f of x plus a, plus is in the direction to the right, we move it to the left, okay? We move it a negative, all right? Because it's that vector there. If it was a negative here, so let's say we had y is equal to f of x minus a, so we're going minus this time, what we would do is we'd move it the vector a naught, okay? A positive. So we'd go to the right by a, okay? So let's have a look at some examples. We've got 3 examples here and we're going to sketch them. So you can pause and have a go if you want to. You should all be able to do part A, but part B and part C, using those 2 rules, see if you can sketch those. Okay, hopefully you had a go. Part A is really quite simple. It's just our general quadratic. It's y is equal to x squared, okay? Passes through the origin and looks something like that. Okay, now I can make mine look quite nice there, like that, okay? It shouldn't be too like that. That's no good. It's kind of got too much flatness there, if you like. And it also shouldn't be really pointy like that. It should be a nice curve. Okay, so that was part A. Part B, what we want to do is sketch y is equal to x minus 2 all squared. So we can see here, we're going to be dealing with this second bullet point. We have got our minus 2, our a here, a is minus 2. We've got that with the x, it's inside the bracket, just like we had here. Okay, so that means what we're going to do is we're going to translate the graph of y equals f of x by the vector minus a naught. And in this instance, our a is minus 2. So because it's a negative, we're going to move to the right, okay? It was positive here, so we had a negative moving to the left. A, we can think about is minus 2, so we've got minus 2, which will give us a positive. So because it's negative here, we're going to translate by the vector 2 naught. Okay, so I can duplicate this graph on here. This is the graph we're starting with, but then we've got x squared, or x minus 2 all squared. So I'm going to move that graph to the right. We're going to move it by the vector 2 naught, okay? And remember, like I said, this is the x, this is the y, so we're going 2 in the x direction and 0 in the y direction. So I can luckily drag my graph here. 2 in the x direction will look something maybe like that, okay? And then to show that we've done the correct translation, I'm going to add this turning point here as 2 naught. And we know that's 2, naught because here we had a turning point of 0. And because we've got this -2 inside the bracket, we're going a horizontal translation of this vector to naught because it was negative here, so it becomes positive. And we moved basically every x point 2 in the positive x direction, 2 to the right, okay? So the turning point here was at 0, 0, so translating it by this vector will make it 2, naught. Okay? All right, let's have a look at part C. We have the x squared function, so y is x squared, but we've got a +2 on the end. So this time we're dealing with the first bullet point. Have a look here, it says the graph of y equals f of x plus a is a translation of our original graph by this vector, 0, a. So nothing in the x direction, a in the y direction. So have a look here, we've got a +2. So we're going to move the graph by the vector 0, 2, okay, because our a value is 2. When we get good at this, we don't actually have to think about moving the vector by the value of a, okay, or the graph by the value of a. We don't need to think about that. We can kind of already see what's going to happen in our head. But just to get our head round this, we can think about the vectors. So we've got a +2 on the end of our function, so we're going to move it 0, 2. So again, I'll duplicate my graph. This is what we started with in part A, and we've took that function x squared and moved it up by 2 because we're doing nothing in the x direction, we're going up 2 in the y direction. So, oops. Let's select the graph and let's move it up by 2 in the y direction. And then if we add a little bit of scaling on our graph here, that turning point is now at, well, 0 on the x axis because we're on the y axis, so x is 0. And then 2 in the y direction because we've moved up by the vector 0, 2. Okay, so that's how we can differentiate between a horizontal movement and a vertical movement. If we are inside the brackets, we do a horizontal movement by the opposite sign, if that makes sense, because we had a negative here, so we moved it in the 2 in the positive x direction. And then if we're just on the end of the function, so x squared plus 2, we're not inside the bracket here, we've just got a +2 on the end, we do something in the vertical direction. In this case it was positive, so we move up 2. Okay, if it was -2 here, we would have moved down 2, so it would have looked something like that. Okay, we would have moved down 2, but it was positive, so we stick with that. Okay, oops, let's add the bracket back on. Okay. All right, so what happens though if you've got a function that has asymptotes? Okay, so maybe we had something like 1 over x squared, we had 1 over the square root of x, something that has asymptotes. We looked at what asymptotes are in a previous video, and they're basically where the function blows up. It doesn't make sense. So for a simple function like 1 over x, we can't have x being equal to 0 because then we have 1 divided by 0, and that doesn't make sense. So let's have a look at an example. Here we are looking at a function h of x, which is 1 over x, and we want to sketch the curve with the equation y is equal to h of x plus 1. Okay, so what we're doing is we're having a function, and we then want to sketch that function but plus 1 on the end. The plus 1, because we're just adding it to the function, moves the function in a vertical direction. And because it is a positive 1, remember right at the start of the video, because it's a positive value here, we just move it, that value, in the positive x direction. We move it by this vector. So let's have a look. I've already sketched h of x for us, okay? 1 over x looks like that, and we looked at that in a previous video. But then we want to sketch the curve h of x plus 1. So pause and have a go if you want to, and then we'll work through the answer. Okay, let's see whether we're correct. So because we've got the +1 outside the bracket, it's just on the end of our equation here. It's going to do a vertical direction or a vertical translation. So h of x we know is 1 over x. So what this equation actually looks like is y is equal to 1 over x plus 1. So I will stick with 1 over x here. What I will do is I'll duplicate this little bit here, and I might actually do this so I can get it all at once. And if we duplicate that and we'll change it to red, then this is the graph that I'm going to be translating or sketching here. Okay, so we'll take the graph, and because we've got a +1, it's going to go up by 1 in the y direction, so a +1 in the y direction. So we'll start at 1 over x, and we're just going to move it up 1. Okay, so starting here, moving it up 1 like that. Okay, so that's what it's going to look like. We're just moving it up by 1. Now, your 1 could be a little bit different to mine. We started here and I moved it up 1 like that, but your 1 could look maybe something like that. We don't have scaling on our graph. So what we're going to need to do is have a think about asymptotes, and that way we can kind of get a better look at our graph. So I'm going to move mine down a little bit and I'm going to have it there. That is my graph moved up by 1. Okay, but what we should have actually noted, maybe I should have done this at the start, is an asymptote on the graph. So if I just change the thickness of my pen, okay, we know from a previous video that the axes are actually asymptotes for 1 over x, okay? Y cannot be 0 and x cannot be 0. So those are asymptotes for the original graph, h of x, okay, 1 over x. If x is 0, we have 1 divided by 0, that doesn't work. And if y is 0, we get 0 equals 1. We had a look at that in a previous video. Okay, so that doesn't work. So that's why those are asymptotes. But it doesn't make sense now for those same asymptotes to work for h of x plus 1, because we can see here this red graph, which is h of x plus 1, 1 over x moved up by 1, intersects an asymptote here. And that doesn't make sense. We can't touch an asymptote. We never touch it. We always get closer and closer, but we never actually touch or cross. So it doesn't make sense for us to have the same asymptotes for our translated graph. So all we have to do is translate our asymptotes as well. Okay, so let's get a red pen here. We'll go with a sort of peachy colour. And all we do is move those asymptotes. Now, all we're doing is a vertical translation here. So anything that is already vertical is just going to stay the same. So in fact, we do still have, and I'll do this as a dashed line, we do still have the y-axis as an asymptote, and we can actually see that here. We're just going to get closer and closer and closer and closer there. But the x-axis asymptote is going to change because we're just going to move from being on the x-axis to 1 up. Okay, if that makes sense. So we're changing the asymptote here to be about there. Okay, and then we can see this graph is going to approach and approach and approach this asymptote, but never touch it. And this graph is going to approach and approach, but never touch it. Okay, but we can actually work out what that horizontal asymptote is. We went from the asymptote y is equal to 0 on the x-axis, okay, and moved the graph up by 1. So this asymptote here, our new asymptote, is going to be y is equal to 1, because we had a +1 on the end of our equation. Okay? And then that really is everything that we have to do. That's all we have to do to sketch our graph. Okay? We're just translating the graph, and we're translating our asymptotes as well.